Hello viewers, welcome to video number 103 of the channel MALACHEMPHILIC, and this video number 103 is the episode number 44 of Chemical Thermodynamics. Topic of this episode is some multiple choice question related to entropy, and this is part 2. Already in part 1 I have discussed few multiple choice question on entropy. So let's see. So, question number 5. The latent heat of vaporization of a liquid is 9720 calorie per mole. Entropy of vaporization is 26.06 calorie per mole per Kelvin. Calculate the boiling point of the liquid. The options are given. Now let's solve it. So, enthalpy of vaporization is given and entropy change in vaporization is given. We know that delta S vaporization, that will be is equal to delta H vaporization divided by temperature, that is the boiling point. So from this equation we can write that is the boiling point is equal to this delta H vaporization divided by delta S vaporization, and the values are 9720 divided by 26.06. Now we'll do the calculation. Approximately, if I consider it is 25, then it will be 25. We have to divide 9720. So it is 375. So it is 220. Sorry, this is 2. So 2 and then it is 8. So 200. So again 220. So this is 220, that means 8. So 200. That means it is equal, approximately is equal to 2 or 388. 388 approximately is equal to 388 Kelvin. 388 Kelvin means approximately that is equal to, I can say, 100 degrees centigrade. Okay, and this is our approximate value. I'll tell you the exact value also. Okay, before that we'll see the answer. Yes, 100 degrees centigrade is there. So answer is C. The exact value will be, that is 372.98. If you calculate exactly, that is 372.98. Okay, now let's move to the next question. Question number 6. 1 mole of a diatomic ideal gas in a closed container is heated so that the temperature rises from 0 degrees centigrade to 546 degrees centigrade. The change in entropy is close to, they have given the options, and CV value is given 5/2R. Here one thing you mark it, it is in a closed container. That means the volume is fixed, volume is constant. Now let's solve. See, number of moles 1, temperature 0 degrees centigrade, that is T1, final is 546 degrees centigrade. So now calculate. So delta S that will be is equal to NCV ln T2 by T1. That NR ln V2 by V1 part will not be there because volume is constant. So here it is N is equal to 1, CV is equal to 5 by 2 R, that means 2.5 into 8.314 into 2.303, then log T2 by T1. T2 is 546 degrees centigrade plus 273, that means 819 divided by 0 degree, that is 273. So here it is 2.5 into 8.314 into 2.303, and this is log 3. So it is coming as 2.5 into 8.314 into 2.303. Log 3 is 0.477. You should remember few log values like log 2 is equal to 0.3010. Okay. Log 3 is equal to 0.477 and log 5 is equal to 0.6990. So this few log value, so these few log values you have to remember. 699. So remember these few log values. Okay, now how much it is coming? So 2.5 into now we'll do this calculation. Already it is written here. So 2.5 into 8. Okay, 2.5 into 8, 25 into 8 means 200. That means 20. 20 into 2, 40. 40 into, say if I consider 0.5, then it is 20. So this value will come roughly is equal to 20. Okay. Now we'll see the option is this 20 joule is there. So answer will be B. Now the correct value here it is. If you do it correctly, this is the approximately I have done it. Correct value will be, here it is 22.83. 22.83, which is close to 20. Okay. Now we'll move to the next question. Question number 7. For the given pressure volume curve for a monoatomic ideal gas, calculate the entropy change in joules per Kelvin per mole for 2 moles. Okay. Now here the options are given. Here one thing you see from this curve, when the pressure is 60, then the volume is almost 24. So what can I write? P1 when it is 60, then V1 is equal to 24. And when pressure is 30, now see the volume is almost 48. So when P2 is equal to 30, then V2 is equal to 48. So that means P1 V1 is equal to P2 V2. What is that indication? That means the temperature is constant. Here the temperature is constant. Okay. Now you see. So N is equal to 2 and we have to calculate delta S. So delta S, temperature is constant, therefore it will be NR ln V2 by V1. N is equal to 2. R is equal to 8.314 into 2.303 into log 48 by 24. So, it is 2 into 8.314 into 2.303, that is log 4824, that means log 2. Log 2 means it is 0.3010. Now we'll calculate approximately 8.3, so we'll take 8 into 2, 16, 16 into 2, 32, so 32 into 0.3, that means 9.6, roughly, approximately. 9.6 means it is close to 10. That is, answer is A. And here if you want to know the exact value, that is 11.52, this correct value is 11.52 joules. Okay. Now, next question. Question number 8. The heat of sublimation of iodine is 6946 calorie per mole at 200 degrees centigrade. The entropy change accompanied with sublimation of 10 gram of iodine is close to, these are the options. Now let's solve it. So, enthalpy of sublimation is given, temperature is given. First we have to calculate the entropy of sublimation, that will be is equal to enthalpy of sublimation divided by T. Enthalpy of sublimation is equal to 6946, and here it will be 200 plus 273, that is 473. So how much it is? It is coming at 6946, and it will be your, so 1, first it is 1, so 473, so here it is 1, this is 2, this is 2, now this 6, then how much it will come? 4, so 4 3 is 12, that is 29, 2, so 4 4 is 16, that means 18. So it is 4. So therefore here it is 4, 2, 3 point. Here it is 0. So 1, 7. 7 if I give. So 2, 7, 473. No? If I give 8. Okay, approximately it is, no need to do it now, approximately it will be 14.7 only. Okay, so this much of calorie, so this is approximate value, so approximately 14.7 in calorie, 14.7 calorie. Okay. Now, you have to, this calorie per mole, this is calorie per mole. We have to calculate for 10 gram. For iodine, molecular weight is, that is 127 into 2, that is 254. 254. So for 10 gram we have to calculate. For 250 gram it is 14.7. So for 10 gram, so 14.7 divided by 254 into 10. This much. Okay. So this will come as, how much it will be? Here it will be 147. So this is 254 and 147. So 0. How much it will go? I think to 5. So do it. That means it is 0, 0, 2. And then how much it will be? Another 0 will come. So approximately it will be 8. 8 we can consider. That means the value is 0.58. This value is equal to, so this is equal to 0.58 calorie per Kelvin. Calorie per Kelvin. Right? Now this value you have to convert it into joules. Okay? From the value of R, you have to convert it into joules. So this much of calorie, 0.58 calorie, that will be is equal to how much of joule from the R value, that is 8.314 divided by 2, because R value is 2 calorie or 8.314 joule is equal into your 0.58. Now this one if you calculate, this will come as 2.4 joule. 2.4 joule per Kelvin. So now we'll see the option. 2.5 is there, no close answer. So answer will be A. So these are the few multiple choice questions or problems on entropy. Hope you have understood. Thank you.